Hello my dear students, in this lecture series of IIT JAM, GATE, NET and SET etc. exams, today's topic is Introduction to Molecular Spectroscopy.
So before we start, let me introduce some books from which you can study spectroscopy. So first one is this Fundamentals of Molecular Spectroscopy. Authors are Colin and Benwell and Elaine M. McCash. So you can buy the 5th edition, that is the latest edition, and this book can be used as a textbook of molecular spectroscopy. So along with this, you can also study some other books of physical chemistry, namely Principles of Physical Chemistry by Puri Sharma Pathania, and I think this book is already you bought. The second one is Physical Chemistry by Atkins and DePaula. And in the 5th semester classes, we have studied in a book, this Quantum Chemistry, including Molecular Spectroscopy by B. Keshan. So in that book also, we'll have some information about the molecular spectroscopy. So mainly, we'll study the book of Benwell and McCash. That means the first one, Fundamentals of Molecular Spectroscopy. So if possible, if you can afford, you can buy this book. This is very good book and can be used as a textbook for molecular spectroscopy. So this is a new branch. So first of all, we have to know what is spectroscopy. Actually, spectroscopy is a branch of chemistry in which we study interaction between matter and electromagnetic radiation as a function of wavelength or frequency of the radiation. So basically, you can say it is the interaction of matter versus electromagnetic radiation, which we are going to study in molecular spectroscopy. So matter means, you already know, matter means that matter is composed of some atoms and molecules, and we will study details about the electromagnetic radiation. So molecular spectroscopy actually refers to the measurement of the radiation intensity as a function of wavelength in some specific spectroscopic methods. Generally, an electromagnetic radiation is allowed to interact with a substance or matter, and the transmitted or absorbed radiation is studied, from which we get various informations about the substance. So the devices by which this type of studies are carried out are called spectrometer or spectrophotometer, which generates some data, in some cases in the form of some graphs or spectrographs called spectra, and by analyzing those data or the spectra, we get informations about the substance or matter. So we need to understand two important things: the electromagnetic radiation and the spectra that's generated by interaction of matter with electromagnetic radiation. So let us try to understand what is electromagnetic radiation. So electromagnetic radiation is a combination of electronic and magnetic components of waves, which have two important characteristics. First of all, the electromagnetic radiation may be considered as a simple harmonic wave propagated from a source and traveling in straight lines except when refracted or reflected. I repeat, that first characteristic is that electromagnetic radiation may be considered as a simple harmonic wave propagated from a source and traveling in straight lines except when refracted or reflected. So this is the first characteristics. And secondly, an electromagnetic radiation is a radiation in which the electronic and the magnetic component of the wave propagate perpendicular to each other, as shown in the figure. And this type of radiation is actually defined by the equation y equal to a sine theta, where y is the displacement with a maximum value of a, and theta is the angle lies between 0 to 2 pi. So along with these two important characteristics, the electromagnetic radiation also follow the other properties of simple waves. Just like the wave, it also follows the relationship that velocity equal to product of wavelength and frequency. That means C is equal to nu lambda, where C is the velocity, nu is the frequency, and lambda is the wavelength. So along with that, you can also remember one important relationship that we will frequently consider, that is the wave number denoted by nu bar, and wave number is actually the reciprocal of the wavelength. That means nu bar equal to 1 by lambda. So now this electromagnetic radiation is actually divided into some regions which are called regions of electromagnetic radiation. So we are going to see what are the regions of this electromagnetic radiation. So in fact, based on the frequency of the radiation, the electromagnetic radiation is divided into 6 regions, namely the radio frequency region or RF region, the microwave region or MW region, the infrared region or IR region, the visible and ultraviolet region, or it is called UV-VIS region, then X-ray and gamma ray region. So the first one, that's radio frequency region, and in the radio frequency region, the frequency lies between 3 into 10 to the power 6 to 3 into 10 to the power 10 hertz. Okay. Then in the second region is the microwave region, where the frequency range is 3 into 10 to the power 10 to 3 into 10 to the power 12. It is followed by IR region, frequency range is 3 into 10 to the power 12 to 3 into 10 to the power 14. The fourth one is the UV visible region, where the frequency lies between 3 into 10 to the power 14 to 3 into 10 to the power 16. The fifth one is the X-ray region, frequency lies between 3 into 10 to the power 18 to 3 into 10 to the power 16 to 3 into 10 to the power 18. And the sixth one is the gamma ray region, where the frequency lies between 3 into 10 to the power 18 to 3 into 10 to the power 20 hertz. So in this way, this electromagnetic radiation is classified into 6 regions depending on the frequency. And as you can see in the table, that from top to bottom the frequency goes on increasing. Okay, or in other way around, you can say that the wavelength goes on decreasing from top to bottom. Okay, so from this table it is visible that gamma ray has the highest frequency while radio frequency has the lowest frequency, or in the other way around, we can say gamma ray has the lowest wavelength and radio frequency has the highest wavelength, because we know that frequency and wavelength are inversely related to one another. So in the right hand side column, you can see that there are some specific types of spectroscopic studies carried out in this particular regions of the electromagnetic radiation. So you can see that in the radio frequency region, we generally study the nuclear magnetic resonance, in short, which is called NMR or nuclear magnetic resonance spectroscopy. Another one is the electron spin resonance spectroscopy or ESR spectroscopy. So this NMR and ESR are two types of spectroscopic studies which are carried out using the radio frequency radiation. Okay, similarly, in the microwave region, we study rotational spectroscopy.
In the infrared region, we study vibrational spectroscopy.
In the UV visible region, we study electronic spectroscopy. In the X-ray region, we study the energy change in inner electrons of atoms or molecules. And lastly, in the gamma ray region, we study the Moser-Baer spectroscopic study. Okay, so from this table is very important. If you can just remember this table, from this table various types of questions may be asked in the exam. Just like for example, that haphazardly this regions will be given and you will be asked to arrange them in increasing order of frequency or wavelength. Or also in sometimes questions may ask like this, that what are the type of spectroscopic studies carried out in a particular region of the electromagnetic radiations. So this table is very important one. So now let me tell you an interesting example of spectroscopy in our modern day-to-day life.
Have you heard about the microwave oven?
I hope you heard it. By a microwave oven, we can easily cook foods. No? So what is done in microwave oven? So
Simply you can say that a microwave oven is a kind of spectrophotometer.
So where the microwave radiation is allowed to strike the food, and interestingly the energy of the microwave radiation is sufficient to excite the water molecules present in the food items. And when the water molecules absorb the microwave radiation, it undergoes rotation and excited into some higher rotational energy levels. So from this higher rotational energy levels, water molecules again bounce back to the lower rotational energy levels, thereby emitting some amount of energy, and that energy is used to cook the food. Okay. So one important thing here, you can say that question may ask that why not other molecules present in the food items will be excited by microwave radiation. So this, that food items contain some carbohydrates or proteins which are generally high molecular weight compounds. So only water, that energy of the microwave is sufficient to excite only the water molecules. Okay. So if whenever you use a microwave oven, never keep the door of the microwave oven open while the machine is switched on. You know why? And this is because if the door of the microwave oven is open, then accidentally that microwave radiation may fall on your skin, in your hand or in your body. So in that case, what will happen?
The water molecules inside our body will undergo rotation and excited to the higher vibrational energy levels, and in that case it will be very difficult for us to survive.
Therefore it is advised that always keep the door of the microwave oven closed when the machine is used. Okay, so you can read these informations about this microwave oven in the book of Benwell and Makers. It is beautifully described there. You can study in your own. Okay, now let us move on to the next term that we frequently come across in spectroscopy is the spectra. Okay, so spectra, what do we mean by spectra? So actually the data obtained from a particular spectroscopic study is plotted in some graphs which are called spectra, and in many cases a spectra may be a plot of in some cases, for example, spectra may be a plot of intensity against the wavelength. For example, in the diagram you can see there that one infrared spectra of ethanol is given. So in that spectra is actually nothing but it is simply a plot of the transmittance versus the wave number of the infrared radiations. And these spectra are actually named as per the spectroscopic studies carried out. For example, the spectra obtained in NMR, nuclear magnetic resonance, or NMR spectroscopy is called NMR spectra. In the same way, the spectra obtained by infrared spectroscopic studies is called IR spectra, and so on. So we may have different types of spectra like NMR spectra, ESR spectra, IR spectra, Moser-Bayer spectra, and like that. So by studying the this spectra carried out on a particular spectroscopic study, we can get various informations about the substance.
This is all about the introduction about the molecular spectroscopy. In my next lecture, we'll discuss about the rotational, vibrational and NMR spectroscopy.